Hello, everybody. This is going to be our help with question of the day 4.7. In 4.7, we have a tennis racket hitting a ball, and the kind of force versus time graph that we get is right here. So right when it comes in contact, it's got 0 force, but then it reaches a peak at 6 newtons, and it comes down to be 0.3 seconds. Now, impulse is what the question is asking. It says, what is the impulse of the racket on the ball? So impulse is equal to the integral from t initial to t final of all of the forces acting on the object in question. All right. And as you know, the integral gives us the area. Okay. Now, because we have a regular geometric figure, all we need to do is get the area under the curve. Okay. So this is just going to be 1/2 height times base, which is going to be 1/2 of 6 times 0.3. Now, you guys, if we look on this graph, this really becomes, even though it says 6, we can, when we see all the divisions, we can estimate to the tenths. And when we get down here, we can estimate to the hundredths there. So we really do have 2 significant digits there. So 1/2 of 6 is 3 times 0.3 is going to give us 0.90. Since the units of force are newtons and the units for time are seconds, we have Newton seconds, which is going to be our impulse, which is the answer to the first question. All right, so what is the impulse of the ball on the racket? Well, the impulse of the ball on the racket, according to Newton's third law, for every action, there's an equal and opposite reaction, and those action and actions are forces, right? And you cannot touch without being touched, and you cannot touch longer. You cannot touch an object longer than the object touches you, right? So it's the same. So Newton's laws, basically, we have equal and opposite forces, So what we would really get is if we were to calculate the graph there of the ball and the racket, it'd just be equal and opposite. So B, we would have an impulse that would be negative 0.90 Newton seconds. All right, so pretty easy. All right, now C, calculate the average force. So you guys remember that impulse is equal to the average force times time. The average force times time, okay? And therefore, we can say impulse divided by time is equal to our average force, which is going to be 0.90 divided by 0.3. Okay, and 0.9 divided by 0.3 is going to give us 3. And again, we have 2 significant digits, and the units for force are newtons. So that is going to equal to our average force. And if we were to look on here, we would essentially have this where this would be 3. So this area in the blue would be the equivalent of the area in the black. So the rectangle would equal to the triangle. Now, you guys, a lot of times in actuality, we're not going to get a graph quite as perfect as that. But we might have to do some calculations with an integral, but we would have to know what the equation to the line is. And since we don't know that, we're not going to do that. And when I give you questions like this on a test, it's going to be something like this, like a triangle or maybe a trapezoid, something like that. All right. So it's saying if the mass of the tennis ball is 0.0577 kilograms, which is about 2 ounces, determine the final velocity of the ball. Okay. So what we're going to do here is, and I did not explicitly state this, but we're going to assume that the initial velocity is 0, as if we're going to hit a serve or just kind of throw it and hit it as such. Okay, so we know that impulse is equal to the change in momentum, which would be mass times the change in velocity, which would equal to mass times v final minus mass times v initial. And since our initial velocity would be 0, we're going to take 0.0577 kilograms, and we're going to multiply it by v final, which we don't know, but we know that's equal to our impulse, which is 0.90. 0.90 divided by 0.0577 is going to give us 15.597, which for two significant digits would round up to 16 meters per second, which is about 36 miles per hour. 36 miles per hour. So not the most impressive serve, but that's what we have. Okay, so finally, we're going to get to E, which is going to be the change in kinetic energy. How much kinetic energy was imparted to the ball? So what we're going to have here is we're going to have 1/2 mv final squared. And because that right there is the initial velocity is 0, we're just going to have 0.0577 times 16 squared, and 0.5 times 0.0577 times 16 squared is equal to 7.38. Okay, so 7.38, and we're going to call that 7.4 joules is equal to the change in